In this video, we're going to be talking about gravitational potential. Gravitational potential. Now assume we have a mass m, so a massive object m, or just a body with mass m. And this is a point A from the mass, and then we have point B from the mass, and then assuming that this is infinity. If you have an object here and a massive object here, it will experience a gravitational force. So, sorry, it's meant to be, so A would go towards M and M would go towards A. However, because this is more massive, then A would be more likely to go towards M, but they will still experience the same force. So here, it'd be a stronger gravitational force. Here will be weaker compared to M, compared to A, due to M. Now, where's the field going? So the field should be going towards the center of the object. So it should be, so these are the radial field lines. So these are the radial gravitational field lines. Gravitational field lines. Okay, so what is the definition of gravitational potential? It is the work done per unit mass, in bringing the object from infinity to a point in the gravitational field. Okay, so the gravitational potential is the work done per unit mass in bringing the object from infinity, because by definition, the force at infinity is zero. By definition, because it's so far away, the object will not experience a force because of this massive M. Here, B will be weaker, but A would experience a strong gravitational force. So the further away you are, the weaker the force. And by definition, F is equal to zero when it's at infinity. So the work done per unit mass in bringing the object from infinity to a point. So you're bringing an object close to the massive object. So you're bringing a unit mass from far away where the force is zero, and you're bringing it closer. Now the gravitational force. So the gravitational force is attractive. It's attractive. There's no repulsion for gravity, and it's always attractive. So the work done is negative. Work done So the work done is negative because you are not doing the work. So naturally, because it is attractive, by bringing the two objects closer together, you're not doing the work because the gravitational field is naturally attractive. So you don't need to put in extra work. So that's why it is negative work. You're not doing the work. What's doing the work is the gravitational field. So the gravitational field is doing the work. So the gravitational field is doing the work. The gravitational force is attractive and it is negative because you are not doing the work. Now, what is Newton's law of gravitation? So Newton's law of gravitation it's the product of the masses times by constant divided by r squared. Actually, let me just write that a bit better. So it's G M. Now, what is force times distance? How would you work done? So work done is force times distance. In this case, force times r. So work done is equal to, so work done, if you times both sides by r, you get rid of one of the r's at the bottom. So you have G m1 m2 over r. And because you're doing it per unit mass, one of the m's will cancel. So that implies it is G m over r. Now remember, it's negative. So the force is negative. So this is negative. So this is negative. All right, so what is the equation? So gravitational potential is equal to minus G m over r. Now we say that the symbol for gravitational potential is V. So Vg is equal to minus G m over r. All right, so that is gravitational potential. It is the work done per unit mass in bringing the object from infinity to that point. Another way to think why it is negative is because you have to do work against the field. So you have to do work against the field to move out of it. So again, the reason why it's negative, so another reason, it's negative because you have to do work. You have negative because you have to do work to bring the object, or move, not bring, move, if you move the object away from the field, to move the object away from the field. So that's another way. It's negative because you are not doing the work in bringing it closer to the massive object. So the field is doing the work. The field is doing the work when bringing the object closer to the gravitational field, Okay, so it is negative because you have to move. If you have two massive objects, so let's just say this is the object, it's normally attractive. So if you're bringing it closer to the object, the field is doing the work. So it's like if you have an object that's dropping towards the center of the Earth, it does it naturally because the field is doing the work. But if the object is on the surface, you have to put energy into the object to move it away from the field. So the field is doing the work. When bringing the object closer to the gravitational field, you're doing negative work. Alternatively, you have to work to move the object. You have to do the work. So you have to work to move the object away from that field. So, well, let's just draw it. So because it is naturally attractive, to move it away, you have to do positive work. Attractive is negative work. And this is mass M.